Hey, I'm Courtney Waterman, your tutor. Lover of anime, manga, and math. And you just tuned into another session of Tutor Me Sempai. Welcome back, everyone. Today we're jumping into a 9th grade topic, graphing inequalities. More specifically, we're going to be graphing linear inequalities on an XY plane. Now, if you're new to my channel, I'll be putting time codes in for this video in the description box below, so use that to skip ahead to whatever part of the video you think is most interesting. As always, if you have any questions whatsoever about what you see here today, or even your own homework, you can always put it in the comment box below, or visit me on my Facebook page at Tutor Me Sempai and tell me all about it there. This video will have 2 examples, so hit that like, smash the subscribe button, and let's get started. Today we're going to be graduating from graphing something like this on a number line to graphing something like this on an XY plane. Now, this is your first step. If you don't know how to do this first step, jumping here is probably going to be too much of a leap, and I don't recommend doing that. So make sure you have this down before we move on to graphing on an XY plane. Now, if you have questions about this, or if you've never done this before, I have a video that breaks down how to graph on a number line, and you can check it out right up here. It will pretty much break down whatever you need to know in order to successfully do this with nice little hints and tips throughout the video. So check out that video, come back here when you feel a little bit more confident, and then we can tackle the XY plane together. However, I will do a quick recap for this just so we know and we're all starting the same point as we move on. So this is going to be graphing this inequality on a number line. In order to do so, you're going to first need to start with your point. Our point is going to be this number here. Whatever this number is here, that is our starting point. We need to figure out if it's included or not included. And the reason being, we need to know if are we going to have a filled in circle or an open circle. And I'm going to put this in different colors just so we don't get too confused. So let's say blue here. We need to know, are we going to have an open circle or a closed circle? Let's put it that way. And an open circle means that 5 is not included. A closed circle means 5 is included. And looking at this, we see it's greater than or equal to. That means 5 is included. So we're going to have a closed circle. So we're going to start with a closed circle here as our first step. Find your point and then figure out, is it open or closed? We know it's going to be closed because it's included. Now, if it was just greater than, it wouldn't be. If it was less than, it wouldn't be. It would just be an open circle. If it was less than or equal to, it would once again be a closed circle because that equals. But we said this is going to be a greater than or equal to. So this is our first step. The next step is figuring out, are we shading to the left or the right of this point? Well, based on your X, we want to find everything greater than or equal to 5. So we're going to be shading to the right of the point. And this is all you have to do. Graphing your inequality on a number line is going to make this look like this whenever you graph it. So I know that was really fast. If that confused you, once again, I have a video breaking this down in a little bit more detail, a lot slower, that you can check right up there. Today, we're going to be moving from this into this, in which we're going to be graphing on an XY plane. Let's see how. So for our first example, we want to graph the linear inequality y greater than or equal to x. And this is our x-axis, and that's our y-axis. So we're going to kind of remember what we did for our inequalities on a number line, and we're going to have very similar steps. The first thing we did for our inequality for a number line was put the point on the line. We're not going to necessarily put the point on the line, but we have to put the graph on the line. But what graph do we put? There's not a function here. Well, we're actually going to look at this inequality and extract the equality out of it. We want to extract the equation out of this. So that's going to look like y equals x. So this inequality, we're going to extract, we're going to take out that equality or the equation, and we want to graph that. Now you can graph this in two ways, similar to how you can do an open circle or a closed circle on your number line. However, for this example, we're going to just graph it straight, and it's going to work. I'll tell you the other way with our second example, but for this example, just graph this line, y equals x, and I messed up. Let's try this again. Close enough. So this is our line y equals x. So y equals x. We want to graph that first. So now that you have your graph, similar to how you had your point on a number line, the next thing you're going to have to do is figure out where you're shading. Now remember, our number line, we shaded to the left or right of our point. We're going to do something very similar for this graph. We're going to shade to the left or the right of our graph this time. Well, how do we pick which one to shade? Well, just like you would for a number line, pick a number. Well, technically, pick a point, because you want the x and y point in order to plug them both into your inequality and see if the inequality is true. That is your first way of figuring out where to shade. I'll give you a shortcut afterwards, but you can always fall back on this method. Pick a point anywhere. Now, I recommend finding your extreme points in a quadrant that doesn't have your line, because if you accidentally pick something that is in this quadrant or in this quadrant and you're not necessarily sure where it lines up, you might shade the wrong area. But you see, there's no line in this quadrant and there's no line in this quadrant. If you pick a single point in one of these two quadrants and it satisfies this inequality, the entire area that that quadrant is going to live on is going to be shaded. Let's pick a point in this quadrant. Let's say we want -5, 5. If you plug in -5, 5, this point right here is not on this line, right? So you see, we picked a quadrant that doesn't have part of the line in it. We have -5, 5. If you plug it in here, is this inequality true? Is y greater than or equal to that x? Well, let's figure it out. So we have 5, right? Substitute for y, 5 is going to be greater than or equal to -5, which substitutes for x. Is that true? That is true. 5 is greater than or equal to -5. So that means everything on this side of the line is going to be true. If you don't believe me, let's pick a point on this side of the line. Let's pick something out of this quadrant. So if this was -5, 5, let's pick this as 5 here, and this is -5 down here. So now our point is going to be 5, -5. So we picked 5, 5, that point here, and we're going to pick 5, -5 down here. Once again, this is not on the line, so we are picking something that is clearly not going to get confused. And if we plug that into our inequality, we're going to have something like, let's see, -5 greater than or equal to 5. Now, is this true? Is that ever true? No. Since this is never true, this point doesn't satisfy our inequality. Therefore, it is not going to be in our shaded region. Once you find a point that either satisfies or doesn't satisfy your inequality, you know where you need to shade. Because the point in this quadrant didn't satisfy, nothing on this side of our graph is going to satisfy. Because we found a point that did satisfy, everything on this side of our graph is going to satisfy, just like our line was. Remember, we had our line and we had our point, and there wasn't any time where you shaded both areas. It's either the left or the right. Similar to this, it's either going to be the left or the right. You're never going to shade in both. So find at least one point that works or doesn't work, and then you can shade from there. But I've kept you in suspense long enough. This is going to be what we're shading. And this just means every point over here is going to satisfy this inequality, no matter what point you choose. Now this line, let's get back to the line. Remember, I said that this is going to satisfy our equation as well, because this is our first example. And I didn't really go into much at the time, but the reason why I said we could just draw it like this, because this is an equals. So you have y greater than or equal to x. That means if it's equal x, it satisfies this inequality. So technically, this line also includes the actual graph. Now, you don't ever have to shade in the graph. You don't have to do that. You can have it one color, like, you know, if it's just black and white, it's probably going to look all the same anyway. But you don't have to worry about shading in. I just want to overemphasize that the line is also included in the shaded region, for this example at least. Now, what was a shortcut? Remember, I said I have a shortcut for you. Let's say you don't want to necessarily pick any points. Let's say you don't want to accidentally get confused if you have something in one quadrant that has a part of your graph in it. Well, your shortcut is going to be very simple. Let's just say you had your graph like this, and it's greater than or equal to something here. Y greater than or equal to something. It doesn't have to be just x. That means that every y is going to be bigger than whatever's on the right. Every y has to be bigger than whatever's on the right. That means you should be able to grow your y almost infinitely, right? Every y, think about it that way. Infinite y's. That means on the left side of your graph, that's the only way you're going to have the infinite y. It goes up to infinity there. If you're on this side of your graph, you can never reach those high numbers because you're always going to be capped by whatever this line is. You can't just grow infinitely and still satisfy this inequality. So whenever you have a y greater than or equal to, or just strictly greater than, you're going to be shading in your left side. If you have y less than or equal to, that means you're going to be capped at this equation here. Your graph here is going to be your upper limit because your y is never going to be more than whatever that expression is. So this is your upper limit. If it's greater than or equal to, or just strictly greater than, you're shading the left. If it's less than or equal to, or strictly less than, you're shading the right. Now let's move on to our example 2. So for our second example, we have the inequality y strictly less than x plus 2. So remember, our first step is going to be graphing our equation. So let's extract the equation, the equality, out of this inequality. We're going to have y equals x plus 2. This is the line that you're trying to graph. However, unlike our first example, I don't want you to just jump into just drawing your line. That's not going to work here. Remember, I told you, similar to how you're going to be graphing your inequality on your number line, and you can do an open or closed circle, you have two ways of drawing your graph on your XY plane. And that's going to depend on whether the equal part is going to be here or not in your inequality. In our last example, we did have the equal sign, so we drew a straight line. However, when you don't have this equal, we actually depict that with a dashed line. This is not going to be part of our shaded region once we figure out where our shaded region is. So let's graph this line here. Y equals x plus 2. So we're going to shift this up 1, 2 here, and we're going to pretty much just draw it like this. So we're going to dash, 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 dash. Now, forgive me, I might be a little curve here. I don't have my ruler, but you get what I'm trying to do. This is not a straight line. It is a dashed line. And that's going to be how we denote y strictly less than instead of y less than or equal to this x plus 2. So that was our first step. Now we move on to shading. So you can either do the shortcut or pick a point and figure it out once we plug it in. Let's do both just to make sure. But let's start with our shortcut first. This is going to be y strictly less than. Now it doesn't matter if it's strictly less than or equal to for the shaded region part. It only matters for the graphing. For the shaded region part, we just care, is it less than or is it a greater than? Because it's a less than, I told you, you're going to be shading on the right. So it's going to be over here. I'm not going to shade it right now, but I want you to see that just by looking at whether it was a less than or a greater than, we know that this is going to be either on the left or the right. Let's pick a point in this quadrant. Let's say we have -10, 20. That's the point we want. -10, 20, and we want to plug it into this inequality and see if it satisfies. If it satisfies, that means we should be shading in everything on this side. If it doesn't satisfy, that means we can shade in everything on this side, because remember, there is no overlap. So x is going to be -10. So we have less than -10 plus 2. Y is going to be 20. -10 plus 2 gives us a -8. 20 less than -8. Is this true? Is 20 less than -8? No. So this does not satisfy our inequality. Therefore, the shaded region is not on the left, but on the right, like our shortcut said. Now to finish this off, all you have to do is shade in your region. This is going to be everything on this side. Like I said, you don't have to draw on that line. And in this case, you don't want to draw on that line because it's a dotted line. That line does not satisfy. So any point on that line won't satisfy. So you can try it and figure it out yourself, but any point on that line will not satisfy. So what is a point on this line? Remember, this line was y equals x plus 2. Y equals x plus 2. So let's say your x is 3, and when you add 2 to it, you're going to get a 5. So the point 3, 5 is on this line. However, 3, 5, when you plug it into the inequality, gives you a 5 less than 3 plus 2, which is 5 less than 5, which is not true. So every point on this line is not going to satisfy this inequality. Hence, why we did a dashed line, which is going to be similar to your open circle when you have a number line. So I hope you're following today's examples, and I hope you see that graphing your linear inequalities on your XY plane doesn't have to be too difficult. And if you understand how to graph your inequalities on your number line, these steps are pretty similar. However, if you have any question about what you saw today or even your own homework, you can always put it in the comment box below or visit me on my Facebook page at Tutor Me Sempai and tell me about it there. If you haven't done so already, remember to leave that like. It really helps the channel by letting YouTube know that you found this video helpful. And if you found the video helpful, so can someone else. So hit that like, hit the notification bell, smash the subscribe button, and share this video with a friend. That's all the time I have for today. So I'm really hoping this helped with your homework, and I'm looking forward to seeing you again next week. I'm Courtney, and this is another session of Tutor Me Sempai.